So this video is not for the faint of heart. Don't say I didn't warn you. And to simplify this entire video, for those who don't want to sit through the entire video and know exactly how micro bevels work, I'll simplify it by saying this: why do two bevels when you can just do one? Now if you want to know why, and I'm warning you, stay tuned. Here's a way too complicated explanation on why micro bevels are dumb. So your knife dulls instantly the second you cut something. The apex folds over or chips from the lack of strength or toughness, from the apex geometry being too thin, and or steel heat treatment not being able to support the geometry that's currently on the knife. Like this $1 knife dulling the second it starts cutting through this sisal rope at 16 degrees per side. Apex damage galore. Now if you're still here after that intro, there's probably something wrong with you, but hey, you want to know how micro bevels work, right? Now since we can't fix the crappy steel or heat treatment, the only way that we can fix this is by changing the edge angle or geometry of the apex by making the apex more obtuse or less acute, depending on how you want to look at it. Since the more steel we have on the apex, the more it helps support that apex when cutting through something. Now a simple solution is to change the entire apex geometry from 16 degrees per side to 20 degrees per side. This will give the apex the support it needs. However, in doing so, we increase the entire bevel thickness, thus in theory making our wedge thicker and decreasing cutting performance by adding thickness behind the area of initial damage. We need to thicken this area and above, not this area and below. So what if we could add geometry exactly where we want to support the area of damage and nowhere we don't? Well, we can. It's called a micro bevel. And essentially a micro bevel is simply another very small bevel added to the apex at a slightly more obtuse angle to help support that apex, but also by not adding any more thickness to the areas where we don't need any more support, keeping our wedge as thin as possible without sustaining damage. Now micro bevels do work. There's no denying the fact that adding more obtuse apex geometry at the apex does decrease apex damage in certain scenarios. Now here's a perfect example of this with a brass rod impact test. We have a cheap, crappily heat-treated D2 steel knife at 17 degrees per side, impacting a brass rod. And here's the damage. This would not be conducive to your cutting performance. Now, we add a 25-degree micro bevel to that same apex with the same test, and we have basically no damage. We stop the damage by adding steel with geometry to the exact area we need it where the knife is thinnest, while keeping the rest of the bevel as thin as possible. However, we do have two other problems. What micro bevels look like in practical applications. The first problem is, can you actually tell a difference in the cutting performance between, in this case, a 17-degree main angle and a 21-degree micro bevel versus just a straight up 21-degree optimized apex angle to begin with? In other words, why not just put one single bevel 21-degree apex angle on the knife and call it a day? Can you actually tell a difference in performance in real life when cutting stuff? Now we did do some completely non-scientific cut testing, just like all of my cut testing, on different stuff, and the results were somewhat inconclusive. I could not tell a difference in cutting performance between a steep angle and micro bevel edge versus a single bevel angle that has been optimized for that specific steel and hardness. So what I mean by optimized is we start with a pretty extreme single bevel geometry, in this case 17 degrees per side, doing what we want to do with the knife. In this case, it's a brass rod impact test. And we change the angle by 1 degree per side until the damage disappears. This would be optimized geometry for this particular task, this particular steel, and heat treatment. In this case, it's about 25 degrees per side. So in the case of a micro bevel, it works exactly the same way. We start with a damaged apex. Add a more obtuse micro bevel right along the apex where the damage occurs at 25 degrees and the damage disappears. But can you tell a difference between an optimized single bevel and a slightly thinner apex and thicker micro bevel? No, you can't. Other than on one specific task, which I was very surprised I could tell a difference in the first place, but I definitely could. And that was cutting sisal rope. Sisal? Fissile. The thing is, it's crazy, is like I can tell a difference here.
So cutting sisal rope, I could tell the slightest difference between an optimized 21 degrees per side for cutting rope versus 17 degrees per side in a 21 degree micro bevel. The difference was small but noticeable cutting side by side, with the micro bevel edge cutting slightly easier than the 21 degree single bevel edge. Now this was only on the rope test. No other cut test was I able to tell a difference whatsoever.
Now the second problem we have here is resharpening. Basically, in order to get an optimized micro bevel, you need to start from scratch every single time when resharpening. You can't just resharpen the micro bevel without turning it into a larger bevel, thus decreasing the very thing that you're trying to do in the first place.
So this micro bevel is 2 extremely light passes on a 1500 grit diamond stone, and simply doing 2 more extremely, I can't stress this enough, extremely light passes thickens up the micro bevel significantly. So if you are completely resharpening a micro, you can't simply maintain the micro bevel if it gets dull. You'll just end up turning the micro bevel into a large single bevel.
So adding a micro bevel can be a quick fix for a damaged apex without completely reprofiling, but eventually, or more realistically, the next time that you sharpen, you'll have to reprofile anyway in order to maintain that minute cutting performance advantage a micro bevel can provide. But you can only really observe when cutting very specific things. So if you thought that this was kind of ridiculous up to this point, the rabbit hole goes deeper. Now, this is actually slightly more complicated than you may imagine, because in my experience, behind the edge thickness is far more important than behind the micro bevel thickness. And what I mean by this is that if your knife has extremely thick behind the edge thickness, you will see more of an advantage with a micro bevel than you will with a knife with a thinner behind the edge thickness. I know this is kind of getting ridiculous.
To simplify this, the thicker a knife blade is here, the more a micro bevel will help performance. And that's because the distance between the behind the edge thickness plane and the micro bevel plane is greater than the single bevel geometry with thinner overall stock thickness from the blade center line or something like that.
I seem to have confused myself here, but to keep this video simple, if you need to go to extreme apex geometry and add a micro bevel to get the cutting performance you think you need, you actually are probably better off with a knife with thinner behind the edge geometry in the first place. So in order to get better cutting performance out of the Scandi grind, I'm going to take the Scandi grind down to 8 degrees per side and then micro bevel it. Or I could just use a thinner knife, proper tool for the job. Basically, you're trying to use a sledgehammer to drive tacks in that scenario. And adding an absolute microscopic advantage of adding a micro bevel to fix a failing apex is microscopic in comparison to the simplicity of just reprofiling to the same slightly more obtuse single bevel angle in the first place.
To simplify this entire video, why do 2 bevels when you can just do 1?
Now I hope this video was super confusing because in general that's what micro bevels are. A way more confusing and time-consuming way to probably not add any more cutting performance to a knife that is way too thick to begin with for a particular task. Or to fix a failing apex with way too thin of edge geometry, which you should probably just reprofile anyway. Thanks for watching. We'll see you next time.